Welcome to 6502 Assembly Language Programming. In this video, we'll look at how to use decimal mode. What is decimal mode? Add with carry and subtract with carry operate differently in this mode using packed decimal format. And what is packed decimal? In packed decimal, each byte can contain 2 decimal digits. And on the slide is the format displayed as binary and hex. So imagine the value 25 being stored in packed decimal. So it'd be stored in 1 byte with 2 in the upper nibble and 5 in the lower nibble. Here's how add with carry works in binary and decimal mode. First, we're going to operate in decimal mode. And so SED, set decimal mode, switches the computer to decimal mode. CLC clears the carry, which we need to do before the add. So we load A with hexadecimal 19 and do an add with carry of hexadecimal 11. So in decimal results, in decimal mode, this results in the value hexadecimal 30, which is what you'd expect if you're doing decimal arithmetic. However, if we turn off decimal mode and then do the same addition, it would result in hexadecimal 2A, which is what you'd expect if you're doing regular binary arithmetic. So let's look at how subtract with carry would operate in decimal versus binary mode. Same thing at the beginning here. We're going to set decimal mode. We're going to set carry. And if you haven't watched that video yet, carry works in reverse on subtract. In other words, a 1 in the carry acts as a 0. That's confusing. I don't like it, but that's how the chip is made. So we're going to load A with hexadecimal 31, and we're going to subtract 2. So in decimal mode, that results in an answer of 29. Again, that's what you'd expect in normal decimal arithmetic. However, if we turn off decimal mode, set carry again, and do the same arithmetic, we would get a result of 2F, which is what you'd expect in normal binary arithmetic. And are you clear that even though I'm saying binary, I'm just showing you the numbers in hexadecimal? What's going on under the hood is binary arithmetic. So why use decimal mode? So it turns out to convert a binary number to displayable decimal, it must be converted first to packed decimal. And that's fairly computationally intensive. And so storing the number as packed decimal saves that step. And so here is a binary to decimal conversion routine. And the main thing that I'd want to point out about this, let me get my red pointer, is that you have this loop here. And this loop is going to repeat for every bit of the input, which is going to be 16 bits, 16 loops. And once you finish this, you still have to convert the packed decimal output into displayable form. And this routine does that. And so this routine, if you're going to display a number, you need a routine like this somewhere. But this one is less computationally intensive. It has one loop for each 2 bytes of output. So, for instance, for in the current situation where we're doing a 16-bit number, it would loop 3 times, which is much less than 16. So you can see the advantage in saving processing time, if you're storing something like a game score or some other total that you can easily store and manipulate as a packed decimal number. So what is the downside of decimal mode? And really I'm saying of packed decimal. So it's less desirable if you're doing math other than addition and subtraction. For instance, if you have to code multiply and divide routines, that's going to be much more complicated with packed decimal than with binary. And there's also the fact that numbers stored in packed decimal are just less compact than in binary. So let's go have a look at this in the IDE. Here we are at the 8 bits in 1 byte website. Let's navigate to the course source code. So I've saved my work from previous exercises here, and so I'm going to click resume work. Now I want to mention that there are videos on how to use the IDE that we're looking at here, and in particular how to save your work and load it up again. For the moment, we're going to go ahead and proceed with the exercise for this video, which is ex9.asm. And actually, this one is really simple. I think you'll be able to solve this pretty readily after watching the first part of this video. So if you want to pause me and go ahead and solve it, please feel free. Otherwise, let's continue. Okay, so our task here is to add 2 packed decimal numbers in param_0, param_1, and store the result in output 0. Okay, that's going to be pretty simple. So we're going to want to do an LD. Well, we want to say enter decimal mode. So that's SCD. And I'm just going to make a silly comment for instructional purposes. So enter decimal mode. And then we're going to clear carry. We always have to clear carry. Well, you don't always have to clear it, but unless you want it to be a random bit, or unless your code knows what it's going to be, you need to carry it. Okay, it was not entirely clear. If you know you don't need to clear it, then don't clear it, but otherwise you should clear it. That's the way to say it. Okay, so now we're going to do load A, and what's the input again? Param_0. Param_0. Okay. I can't think of a comment to put there. We're going to add with carry param_1, and then store the answer in, I think it was output 0. Output 0. Oops, kind of scrolled off the edge of the world here. Output 0. Okay. And then we want to change this to implemented, letting the test code know that it should look at our answer. Okay. Oh, the other thing we want to do is we want to get out of decimal mode. And let's go ahead and run that. You look over here to see if you've had any build errors, and we didn't. And okay, this green light is tells us that we got the solution right. And a good way to do this, this might be confusing. If you see, I've done all these exercises, and for some reason I lost my work on those two. But a good way to solve the problems is to start off by changing this LDX to implemented before writing any code. So like we could go ahead and get rid of all of our code, change that to implemented, or leave that as implemented, and then run it. And then we should get a big fat red light here in the appropriate spot. So now we know we want this one to turn green. So let's go back to the source. And I'm just going to paste my code back in. And then run it again. And you see now it's green. And let's go ahead and step through that. It's really pretty simple, but just for completeness, we're going to put a breakpoint here. So first we're going to set decimal mode with the SED instruction. We'll step over that. We're going to clear the carry flag, and you see now carry flag is 0, decimal mode is 1, the D flag over here is 1, and we're going to load A from param 0. And if we look at the A register, we have 19 there, and we can see that param 1 is at 81. Let's look at the log pane to look at memory, and you see that 81 is 29. So in decimal, 29 plus 19 is going to be 48. So that's what we expect to see in output 0, and in fact in the A register after we step. So here we have 48 as we expected. So we'll store that in output 0. We'll clear the decimal mode indicator. So that's going to go from 1 over here to 0. And then we're going to claim that we're done. And the test code should look at our result. So we'll clear this breakpoint and resume. And you can see that we in fact have passed the test here, and we're done. Okay, this is a pretty simple exercise, but I think it's enough to show you how decimal mode works and how packed decimal arithmetic, at least, or packed decimal addition works. So thanks very much for watching this video this far, and pardon the scrolling back and forth, I gotta stop doing that, and you have a great day. Don't forget to like and subscribe. And now I'm going to go find out where my work went for these two exercises.